Alright, so today I'll just check few items on Advantest R6581T, and we'll see how it goes. There is a big thread about this meter on EV blog forum, and there are a couple concerned users providing the feedback. Let's get back to it. So there are a couple tests we can try. Follow this procedure to do some quick checks, and I prepared a test setup just exactly to do that. So right now I have two meters connected to the 10-volt reference. So this is the unit under test, 6581T version, and the reference meter is the bottom 3458A. So right now, as you can see, there is 10-volt measurement. It reported around 10. Okay, zoom in more closely. So that's the reading, 10,000,242. And right now I have the autozero enabled, and the issue which some forum users saw is with the autozero enabled, there is a noise injected into the reference. So right now I have autozero enabled, and I can go over and show other settings. I have protection enabled, 8.5 digit mode, 110 PLC. And we're reading voltage as normal. And here is the scope capture of the reported noise. So the horizontal and vertical bars, that's peak-to-peak reading is 1.2 microvolt. And because the scope doesn't have so sensitive range, I use one of the low noise amplifiers from EV block member pipeline, and those amplifiers provide gain of 10,000. So they look like this. And they have the battery power, have the integrated charger using micro USB connector, and have the indicator to show that op amp is working in correct range, and a nice power off, power on switch. So really nice and handy tool for testing reference sources noise. So as you can see on the scope, let me get a bit closer. Alright, here we go. So this is plus minus 1.2 microvolts, and the noise is around, if I'll stop the capture. Let's peak to peak would be, oh, this is 1 microvolt, 1.04 microvolts, and this is the horizontal scale is 1 second per division. So you have from, this is the total 0.1 hertz. So this is low frequency noise measurement. And the reference for this case is box right over there. That's the modified Flux 792A power pack, which is just the battery source, and also it's have LTZ 1000 reference in there. So I can switch to the battery operation, and we can make sure that there is no difference in noise response. So right now reference is running on the battery and connected to the Advantest meter. So what I'll do now is turn off the autozero, and let's see if we have any difference. So right now autozero disabled. So we can set the cursors. So the noise is around 0.96 microvolts. There are a couple outliers, but in average it's around 1 microvolt per peak to peak. Now I can enable autozero. Autozero is enabled, and actually I have this running for already more than 30 minutes, and I couldn't actually see the difference between enabled or disabled autozero in the terms of low frequency noise. Maybe we can add the measurement for min max. And we can set the scale to 10 seconds per division. Make sure we have enough resolution. So I'll let this run, and then we can disable autozero again and compare the readings. Everything looks uniform. Take this blinking stuff. It's just because the update is very slow with these long scales. Okay, we'll almost get 100 seconds of samples, and let's stop this. So we have maximum peak to peak 1.25 microvolts peak to peak. We can actually capture this screenshot. Save the data. And now we can do the same measurement, but with autozero disabled. So you can see like it's barely faint and visible. Autozero label there. So now I autozero disabled. Now we can restart the measurement. And see if it have any lower noise. Everything looks about the same. Okay, we can stop. And yes, this is 1.3 microvolt. If we don't include the outliers, then about the same, 1.2, 1.1 microvolt peak to peak. So I would say there is no difference in the if it's autozero enabled or disabled, at least on this 10 volt range and with this reference. Now if I would use unbuffered reference, perhaps there would be some more visible difference, but the reference I use in here is buffered with the dual chopper op amp output. So we can also verify that if I connect the bottom meter, the 3458A number 3, I'll switch the terminal to front and turn on the autozero on the HP meter. And also change the terminal to rear. So we essentially disconnect Advantest meter, and we can go back to our scope. And I don't see any difference. So the noise wise is all about the same. So I would say my particular Advantest meter doesn't have this noise spike injection issue in this specific condition. Now I can connect the Advantest meter back to the scope. Select input to front and enable autozero. There we go. And there is no any change in the noise. So, okay, I think we can close the question with the noise for this specific condition. And we can go ahead with the second reported issue with the variation between of the same resistor between 1 megaohm and 10 megaohm ranges. So